Okay, so today I'm going to finish these notes. It's the 6.4 factoring and solving polynomial equations. If you missed this first page, I did that yesterday. So you'll need to check that notes to see these, but these all are finished. So now I'm going to complete the notes. So we're going with example 2 on the top of the second page. Now we're going to be doing factoring by grouping. Alright, so factoring by grouping, what you're going to do is you're going to group the first two terms together, and then you're going to group the last two terms together. Now, the last two, make sure you include the sign in with this one. So what you got to do is you got to look at just the first two terms, and you got to figure out, well, what can I factor out of those? We have an x cubed and 2x squared, so we can factor an x squared out of both. So we're going to factor that x squared, and we're going to put it out front of this parenthesis. And then we're going to divide each of these by that x squared. And then we're going to put what's remaining in there. So x cubed divided by x squared leaves us with an x. The minus sign. 2x squared divided by x squared. The x squared cancels out, so it leaves us with a 2. Alright, so now we have a x minus 2 in the first set of parentheses here. We want to get the same thing in this back set. So we got to look at it and say, well, what do I got to factor out of this that's going to leave me with an x minus 2? And the answer to that is a negative 9. So we factor out a negative 9, we put it up front, and then we divide each one of these by that negative 9. And it leaves us with an x minus 2. Alright. Now what we're going to do is we're going to take what's in front of each set of parentheses. So we're going to take this, and we're going to take this, and we're going to group those two together. So they go in their own set of parentheses. So I got an x squared minus 9, and then I bring down one of the x minus 2's. Alright? Once I do that, now I can see that the x squared minus 9 can still be factored out. That is our difference of perfect squares. So to finish this problem off, we want to write x minus 3 times x plus 3 times x minus 2. Alright, and that's how you do factor by grouping. Alright, example 3. We're going to factor these out. Now these are some different types of factoring. The first one, this is actually the difference of perfect squares. Because this is a perfect square and that's a perfect square. So we're going to factor this out using the difference of perfect squares, which what we do is, again, two sets of parentheses. The square root of the first term goes in the front of each, so 9x squared and 9x squared. The signs are different. And then the square root of the back goes in the back. Now you should notice that in the back set of parentheses, we have 9x squared minus 4, so that's still the difference of perfect squares, so we can do that again. The front one has a plus sign, so that's not. We can't do anything with that. So we just bring down 9x squared plus 4. And then the back one, we do two sets of parentheses. Square root of the first term goes in the front. Signs are different. And the square root of the back term goes in the back of each one. And now we have it factored out completely. And that's what you're going to have to do with these. Make sure you factor them out completely. Alright, so then B on this one. Now we have our three terms, but again, we should see that we recognize that we can factor out a common factor. Alright, the common factor is 4x squared. So we're going to factor out a 4x squared, and that's going to leave us with an x to the fourth minus 5x squared plus 6. Alright, now we can factor out this trinomial right here because there's no leading coefficient. We're going to keep our 4x squared, and what we're going to do is we're going to make two sets of parentheses. And what are we going to put in the front of each one? Well, we need an x to the fourth, so I got to put an x squared and an x squared. All right. Now we're going to do it the same way we would have done it if this would have just been an x squared and an x. So now we want the factors of 6. Then when we add them up, we get a 5. And the factors of 6, when you add them up, you get a 5, or 2 and 3. And the last sign's a plus sign, so that means the signs are different. The signs are the same, and they are both minus signs. All right, now just to check real quick, make sure we don't have the difference of perfect squares again. 2 is not a perfect square, so that's not the difference of perfect squares. 3 is not a perfect square, so that's not the difference of perfect squares. So we have that factored out completely. All right, now example 4. Example 4, here's why we're learning how to factor all this stuff, is we're actually going to solve this polynomial equation. So solving this one, we have to get a 0 on one side. So we subtract 14x cubed. 14x cubed. So now we bring it down. 2x to the 5th minus the 14x cubed plus 24x equals 0. Alright, so then the first thing we do is we factor out the common factor. Alright, and the common factor here would be 2x. So we factor the 2x out. It's going to leave us with x to the 4th minus 7x squared and then plus 12. So now we have this, our trinomial. Alright, so on that one, we don't have a leading coefficient, so we're going to try to factor it out. We just drop our 2x down, and 2 sets of parentheses. And again, we need an x to the 4th, so we're going to put an x squared and an x squared. Alright, last sign's a plus sign, so signs are going to be the same, and they're both going to be minus. And then we want our factors of 12 that add up to 7, and the factors of 12 that add up to 7 are 3 and 4. Now, we have an x squared and a minus sign, so we check to see if we have the difference of perfect squares. 3 is not a perfect square, so that's can't be factored out any further. But the 4 is, so we can factor that one out further. So we're going to drop these 2 down. And we're going to factor these 2 out. All right, now since we have an equal sign, we're going to finish this off by solving this. All right, so again, our zero product property says you take all the factors, you set them equal to 0 and solve. So we're going to start with our 2x. So we take our 2x, we set that equal to 0, we divide by 2, and we get x equals 0. We take our x squared minus 3, we set that equal to 0, we add 3 to both sides. We got x squared equals 3, and then we do the square root plus minus. We get x equals plus or minus the square root of 3. And then we take our x minus 2 equals 0. We add 2, and we get x equals 2. And then we take our x plus 2 equals 0. We subtract 2, and we get x equals negative 2. So we have 5 solutions for this problem. Alright, our 5 solutions are x equals 0, x equals a positive square root of 3, x equals a negative square root of 3, x equals 2, and x equals negative 2. Alright, so you have the try these. Alright, there are 6 try these problems, so you should pause the video right now and then do the try these. The first 3, all you're doing is factoring. The bottom 3, you are solving. Alright, so again, top 3, just factoring. The bottom 3, you are solving. Alright, so you want to pause the video right now. Alright, so number 1, you should have noticed that these are perfect cubes. So we're going to have the sum of perfect cubes. So again, we got to figure out what the A and the B are. So x to the 6th is actually x squared cubed, and then 125 is 5 cubed, right? So now we know our a is x squared and our b is 5. So we're going to do our formula. So our formula says it's a, which is x squared, plus b, which is 5, times a squared. So now we got to do x squared squared, which gives us x to the 4th, minus a times b, so 5 times x squared, or x squared times 5 gives us 5x squared, and then plus b squared. And now we have it factored out. All right, number 2, you should notice there's 4 terms. Anytime you see 4 terms, you're always going to look to factor by grouping. So again, we do 2 sets of parentheses. In the front, we can factor out a 4x squared. Leaves us with x plus 4. In the back, we already have x plus 4, so what we do is we factor out a positive 1. So now we group what's in front again. So the 4x squared with the plus 1. And then bring down an x plus 4. All right, number 3, we have the difference of perfect squares. So the difference of perfect squares, again, 2 sets of parentheses. Square root of the first term goes in the front. Square root of the back term goes in the back. And the signs are different. Well, we can't do anything with the 1 and with the plus sign, so we can just bring that down. But with the one with the minus sign, that's still the difference of perfect squares. So that still factors out to x plus 1 times x minus 1. And those were the 3 that we were just factoring. Now we have the 3 that are solving. Now, the key to this is it says find the real solutions. All right. So when we factor this one out, again, this is going to be our difference of 2 cubes. So again, we rewrite it as x cubed minus 3 cubed. We use our formula, the one with the minus sign, so it's a, which is x, minus b, which is 3, times a squared, so x squared, plus a times b, 3x, and then plus b squared. So 3 squared gives us 9, and it's equal to 0. Now we set our x minus 3 equal to 0. We solve it, and we get x equals 3. If you take x squared plus 3x plus 9, you set that equal to 0. If you find the discriminant for this, the discriminant is going to be negative, so that tells you that there is no real solution for that one. There's 2 imaginary solutions. The problems say only find the real solutions. All right. All right, the next one, number 5. We're going to get the 0, so we subtract the 28. We have 3x cubed plus 7x squared minus 12x minus 28 equals 0. We group the first 2 together and group the back 2 again because we had 4 terms. So we factor out what we can. We can factor out x squared. Leaves us with 3x plus 7. Now we have to figure out what do we factor out of this to give us a 3x plus 7, and that is a negative 4. So negative 4 leaves us with 3x plus 7 equals 0. Again, we group what's in front, so x squared minus 4. We bring down one of our 3x plus 7s equal to 0. X squared minus 4, that is a difference perfect square, so we factor that out further. X plus 2, x minus 2, and 3x plus 7 we bring down. Now all we do is we set all these equal to 0 and solve. So x plus 2 equals 0 gives us x equals negative 2. X minus 2 equals 0 gives us x equals positive 2. And then 3x plus 7 equals 0 gives us x equals a negative 7/3. And there's 3 solutions for that one. All right, and then number 6. Number 6, again, we're going to get our 0, so we subtract the 18. We we have x cubed plus 2x squared minus 9x minus 18 equals 0. And now we got 4 terms. So again, 4 terms we're going to factor by grouping. Group the first 2, group the back 2. First 2 we can factor out x squared. Leaves us with x plus 2. The back one we can factor out a negative 9. And that'll give us our x plus 2. So we factor out that negative 9 and get x plus 2. Then that group what's in front again. And we got x squared minus 9 times x plus 2 equals 0. Again, the difference of perfect squares. So our x squared minus 9 becomes x plus 3 times x minus 3. And then bring down our x plus 2. And then set them all equal to 0 and solve. So we set the x plus 3 equal to 0. We get x equals negative 3. Set x minus 3 equal to 0. And we get x equals 3. And set x plus 2 equal to 0. And we get x equals negative 2. And that's it. I'm not going to do the word problem for this. All right. What I do want you to do now is I want you to go to 6.4 practice C worksheet, and what I want you to do is I want you to do 7 through 37 odd. So this is what you're going to do. This homework is a 6.4 practice C 7 to 37 odd for tonight. And that's it.